Hello, my dear mechanical and civil engineers. How are you all? What's up? कैसे हैं सब लोग? Please guys do join me fast, and those who are already here, respond me through the comment section if my audio and visual quality are fine. Can you guys properly hear me? Am I audible and visible to all of you? So you are watching me live to this foundation course which is running for GATE 2025 aspirants. All right. Jasil, good evening, welcome. Everybody else, please do join me fast and respond me through the comment section. We are going to talk about fluid mechanics in today's session. Foundation course is for those who are preparing for GATE 2025 and they have just started their preparation. If the students are not very much comfortable with the concepts, so we are here to help you out to understand all the important concepts which are very important for your examination, and we try to make those concepts simple and easier for you to understand. So please do not forget to like, share and subscribe our YouTube channel. Alright. So today we are going to talk about the Pascal law. Please do let me know how comfortable you are in Pascal law. So for the next 4 days, including today, we will be discussing about various concepts of fluid mechanics. This is the entire schedule for fluid mechanics starting today. Today we will be talking about the applications of Pascal law, and tomorrow we will be discussing about hydrostatic law. These are the two important laws in understanding the pressure. Then on 28th of March, we will be talking about hydrostatic forces. The timing will be 6 p.m. every day. And on 29th of March, that is on Friday, we will be talking about buoyancy and Archimedes principle. So these are the various topics of fluid statics. What do you understand by fluid statics? Anybody? So the session will be more better, more fruitful if you will involve yourself as much as possible. बताइए, what do you understand by fluid statics? Fluid statics. If you want any other session from the fluid mechanics, you can just let me know through the comment section. So before I start my session, this is my quick introduction. My name is Chandrasekhar. I am mechanical engineering graduate from IIT Delhi and also cleared engineering services examination which is conducted by UPSC. I have worked in Steel Authority of India Limited for a couple of years, and from last 11 plus years I have been into teaching, guiding the students who are preparing for various competitive examination, and I am quite comfortable in fluid mechanics, heat transfer, thermal and industrial engineering. These are all the other subjects are for mechanical engineering branch, but this fluid mechanics is common for mechanical as well as civil engineers, and those who are going to appear for engineering science also. This fluid mechanics is going to be very useful. All right. So those who have joined me recently, once again I welcome you all. Namaskar, Adab, Shubh Sandhya, good evening, Sat Sri Akal, Assalam Walaikum, Wanakam. Please get yourself settled down fast, and this is my email ID if you want to have anything to discuss with me regarding your preparation, any doubt, and if you have anything to discuss, then you can always connect with me through my official mail ID, or it is better if you join me on the Telegram. My Telegram channel is Mechanical by Chandrasekhar, and the link is also there. Already there are more than 1500 students are part of my Telegram channel who are preparing for various competitive examinations. So if you will join such a large group where everybody is aspiring to crack any competitive examination related to mechanical and civil engineering, then it will definitely be beneficial for you. All right. And you can join my Telegram channel by scanning this QR code also. All right. So shall we start? Give me yes, everybody who are live, watching me live. Please do let me know if you are all ready to go. Shall we start? Every one of you. Shall we start? Keep your pen, notebook and calculator also, because it will help you to write down the important points. It will help you in solving the questions which are also there in the session. So the session is the combination of some important theoretical concepts and along with that some numerical problems also to help you understand the concept in detail. All right. So before I start, there is a question, basic fundamental question for you, all of you. What the pressure is a? The pressure, is it a scalar quantity? Is it a vector quantity or is it a tensor quantity? Who will tell me the correct answer about a pressure denoted by P? Scalar is one which is represented by magnitude only. Only magnitude is required. For an example, mass. Mass is a scalar quantity. Only magnitude is required to represent the mass. Vector quantity is the one which requires magnitude as well as direction. For an example, force is a vector quantity. Along with the magnitude of force, the direction in which it is applied is also important. The third type of quantity, physical quantity, is a tensor quantity, which requires magnitude plus direction as well as plane of action. For an example, stress. Stress is a tensor quantity. Stress, we want to have the magnitude, we should have the direction also, and we should also be having the plane of action of this stress. The stress is developed in which plane, as based on that we can classify it to be the normal stress or shear stress. So my basic question to all of you is, so do not get afraid of committing mistakes. If you do not know the answer, but if you will give it a try, then it will help you to understand in a better manner. Yes, everyone. I am not able to see your comments. Are you writing in the comment section? I want everyone. This is my humble request, guys. Please keep on writing in the comment section. Whether your answer is correct or not, there will not be any punishment. There will not be any gifts. So do not get afraid. Yes, unique programming has said vector quantity. What about others? Are you with unique programming? Stress is a quantity which is, sorry, pressure is a quantity which is scalar, vector or tensor. Pressure is a, now time to reveal the answer. Pressure is a scalar quantity. So many students are having this doubt whether pressure is a scalar, vector or a tensor quantity. Pressure is not a vector, pressure is not a tensor. People have this doubt because pressure develops the force, pressure force, and force is a vector quantity. Because force is a vector quantity and pressure multiplied by area represents the force. So students have a doubt that pressure might be a vector quantity, and some of the students have this doubt that pressure might be a tensor quantity. But to your surprise, pressure is neither a vector nor the tensor quantity. It is simply the scalar quantity. For representing the pressure, we only require the magnitude similar to mass. All right. We do not say pressure in X direction, pressure in Y direction, or pressure in Z direction. Yes, Uday, pressure is a scalar quantity. So can you just let me know what do you understand by the term pressure? What is a pressure? So today's session we will be talking about Pascal law, and for understanding the Pascal law you need to understand the significance of pressure, why there is a need to represent the pressure, define the pressure, and what is the physical significance of pressure. Pressure is denoted by P. The standard notation is P. So what is the pressure? Pressure is simply the force per unit area. Isn't it force per unit area? Pressure is force per unit area. But what you need to understand here is, what you need to keep in mind is, the force and area must be perpendicular to each other. Force and area, when force and area will be perpendicular to each other, then they will develop the pressure P, force per unit area. So it can be defined as the normal force per unit area. Pressure is a normal force, perpendicular force per unit area. The unit is Newton per meter square, or this is SI unit. MKS unit, what is MKS unit? Newton can be written as kilogram meter per second square into 1 by meter square. So what is the unit of, what is the dimensional formula for pressure? It will be, can we call it as kg per meter second square? Sometimes the direct questions are asked regarding this quantity. The dimensional formula will be m1 L minus 1 T minus 2. Isn't it? Kg per meter second square. Newton is mass into acceleration multiplied by 1 by meter square will give the pressure. So this is the standard unit of measuring the pressure. Newton per meter square can also be called as Pascal. In the name of Pascal, the unit of pressure is given the name Pascal. All right. So it is simply the compressive stress at a point in the fluid, which is normal force per unit area. When the force applied is normal to the area, so force, normal force divided by area will give rise to pressure. There are few other units of measuring the pressure. The unit of measuring the pressure is bar. Can you convert it? Can you convert bar into kilopascal? 1 bar will be equal to how many kilopascal? One bar will be equal to, can you let me know how many kilopascal, everybody? 1 bar, another unit of measuring pressure is bar. Very common unit of measuring the pressure. Yes. In kilopascal, how much is it? And is Pascal or Newton per meter square, how much is that? You should be able to convert. 1 bar is equal to 100 kilopascal, or it is 10 to the power 5 Pascal or 10 to the power 5 Newton per meter square. 1 bar is equal to 100 kilopascal or 10 to the power 5 Newton per meter square. These are very, very simple parameters, simple units, but you can get a tough question from the unit conversion as well. Yes, the next unit will be another unit which can be used is kgf per centimeter square. kgf per centimeter square. 1 kilogram force is 9.81 Newton. 1 centimeter is equal to 10 to the power minus 2 meter square. So this will be Newton per meter square or Pascal. This is another unit. One more unit we can use, 1 atm, atmospheres. Another unit is atmospheres. Yes, Uday, well done. Trupti, good. Keep it up. So 1 atm is how many Pascal? Or how many kilopascal or how many bar? 1 atmospheres is equal to 1.013 bar, or we can say 1.013 into 10 to the power 5 Pascal. This is how we can convert any other unit into standard unit, that is Newton per meter square. Do you understand this? Everybody, is this all clear? Yes. Now again the question remains same, that is why there was a need to define the pressure. What is the physical significance of pressure? Why do we require a quantity named pressure in our physics, in our science? Anybody? Well done. Unit programming. Good. Keep it up, guys. So why there is a need of defining the pressure? What is the physical significance? We can say pressure is nothing but pressure is effect of force. What is pressure? Pressure is the effect of force. Sometimes the magnitude of force is not important. Effect of normal force, we should say it is the effect of normal force. What is normal force? The force which is applied normal to any area. So it gives the effect. Sometimes more than a parameter, effect is important. For an example, if you are applying 100 kilonewton of force to a particular area, and if you applied 1000 kilonewton of force to another area, will they be equal? Which is more? If I ask you, which will give you more impact, which will give the more effect, we cannot compare the amount of force. We cannot say 100 kilonewton will give the less impact, 1000 kilonewton will give more impact. So impact is important in physics, in understanding the basic science. So the effect of force is quantified by the property or the parameter named pressure. So if the force applied is same, listen very carefully, if the force applied is same, if the force applied, what is pressure? Pressure is normal force per unit area, isn't it? Pressure is normal force per unit area. So we can say if force is constant, applied force is constant, then the effect of this force is inversely proportional to area. Yes or no? If the applied force is constant or same, if we apply same amount of force, then their effect may not be the same. Why? Because it all depends on the area over which this force is applied. So the pressure is inversely proportional to area, and that is the reason you can say blade, knife, blade, or nails all have sharp edges. Why the edges are sharp? Because of having the sharp edge, area over which the force is applied is lesser, area over which the force applied is lesser, then the pressure will be higher, isn't it? Area will be less, pressure will be more. Do you agree? So less area will give more effect. Less area will give more effect, and that is why a knife, a blade, a nail can easily penetrate into the vegetables. Similarly, if you see another examples, the strap of our bag, strap, they are broad, isn't it? Broad strap. Or you can see if the width of the feet or the area, feet area is more, this is having more area, this is also having more area. If area is large, then the pressure will be less. And that is the reason school bags are having the broad strap, so that we feel less pressure. Are you getting it? The girls using the heels, there is less area and that gives the high pressure. So pressure and area are inversely proportional to each other. So pressure is nothing but the effect of the force applied per unit area. It is the effect of the force, right? I hope this is clear. That is the reason of defining the pressure. And so many students have this confusion. What is the basic difference between pressure and stress? What is the basic difference between pressure and stress? The units are same, Newton per meter square or Pascal. The unit are same, Newton per meter square or Pascal, but still there are lot of differences between pressure and stress, isn't it? So, and it is very favorite interview question, viva question during your engineering. Or interview question in any of the competitive examination. So there are some basic difference between pressure and stress. You need to understand this. First of all, pressure is the external force per unit area. Pressure is an external force, whereas stress is internal resistance force. That is the basic difference. Pressure is external force per unit area, whereas stress is internal force per unit area. And the second difference is pressure is developed when the force is always normal to the area. The force must always be normal to the area. That is how the pressure is developed. But in case of stress, it may not be the normal to the area. It need not to be the normal to the area. Pressure is the scalar quantity. Only magnitude is required, whereas stress is a tensor quantity of second order, which requires magnitude plus direction plus plane of action. I told you stress is a tensor quantity. The next point about the pressure is because it is a directionless quantity, so it will be same in all the direction at a point. It is same in all the direction at a point. It will be same in all the direction at a point. But stress need not to be the same in all the direction, because it is a tensor quantity. Direction is important. And pressure, because it is a external force per unit area, it is an external quantity, so it can be measured using pressure gauges. There are instruments which are measuring the pressure at a point. We can have the pressure gauge to measure the pressures, and the stress can only be calculated. They cannot be measured because it is internal resistance. Internal resistance can never be measured. Internal things cannot be measured. They can only be calculated from the external parameters. Using the external parameters, using some formula. So stress can never be measured. It can only be calculated. And the pressure develops stress. Which stress? The pressure develops the normal stress, sigma. Pressure develops the normal stress and normal compressive stress. We can say pressure always develops the normal compressive stress. That was the definition. That was the definition earlier. Compressive stress, normal compressive stress per unit area. Whereas stress may or may not produce pressure. The shear stress, tau, does not produce the pressure. Shear stress does not produce the pressure. So these are the basic difference between pressure and stress. I hope this is clear to everyone. Is this all clear? Can we proceed further? Yes, there is a question and then we will start moving to Pascal law. There is a question on the screen. Everybody, Which one of the following pressure units represents the least pressure? They are units, various units. Now we need to find out which one of them will represent the least pressure out of them. 1 millibar, 1 millimeter of mercury, 1 Newton per millimeter square, or 1 kgf per centimeter square. Convert each one of them in Newton per meter square or Pascal. First of all, you need to convert everyone in Pascal. 1 millibar is 10 to the power minus 3 bar into 10 to the power 5 Pascal. So it will be 100 Pascal, isn't it? 1 millibar is 100 Pascal. 1 millimeter of mercury. So density of mercury 13,600 into G into H, 10 to the power minus 3. So it will be 136 Pascal. 1 Newton per millimeter square, 1 convert millimeter, so 1 upon 10 to the power minus 3 square, so it will be 10 to the power 6 Pascal. 1 kgf per centimeter square, 10 upon 10 to the power minus 2 square, so it will be 10 into 10 to the power 4, that will be around 10 to the power 5 Pascal. So these are the convergence of different units in same unit, isn't it? So which one of them will represent the least pressure? Which one of them will represent the least pressure? You can easily say A will be minimum, then B, then D, and then C. This will be the order. So the answer to this question is A. Millibar is minimum. 1 millibar is minimum compared to 1 millimeter of mercury, then 1 kgf per centimeter square, and finally 1 Newton per millimeter square. Yes or no? Yes or no? Tell me, is this all clear? Do not forget to like and share this session, guys, so it reaches to all those aspirants who have just started their GATE 2025 preparation. Now let us move to the very, very important, very, very beautiful, wonderful concept, which is called as Pascal's law. Let us talk about the Pascal law. I will discuss the Pascal law in 3 important steps or 3 important statements. The first statement says pressure at a point in a static fluid. What is a static fluid? I asked you this basic question. Who will tell me what do you understand by the static fluid? What do you understand by the static fluid? Everyone. Static fluid जो रुका हुआ है, that is static. Water in a moving container, is it a static fluid or moving fluid? Water in a moving container, will it be static or moving? So pressure at a point in a static fluid. Static fluid is the one which is having no relative motion between their particles. The fluid particles are having no relative motion, or we can say there is no angular deformation in the fluid. There is no angular deformation, or we can say there is no flow, or we can say tau is equal to 0. Shear stress developed will be 0. Whenever the shear stress developed in the fluid is 0, the fluid is said to be static fluid. So pressure at a point in a static fluid is equal or is same in all the direction. It means the pressure in x direction will be same as pressure in y direction will be equal to pressure in z direction. Pressure will be same, P. It is direction independent quantity, or we can say even in moving fluid, even in case of moving or flowing fluid. Even in case of moving or flowing fluid, static pressure will be same in all the direction. Static pressure will be same or equal in all the direction. So even if the fluid is flowing, or we can say even if tau is not zero, the shear stress is not zero, the static pressure will be same in all the direction. That was given by Pascal, and that is why it is known as Pascal's law, and in the memory of Pascal, the unit of pressure is given as Pascal only, right? Now you can practically demonstrate the statement of Pascal law. How? If you take a liquid in a container having the holes, there are holes in a container and there is a viscous liquid. If you take a viscous liquid in a container having multiple holes and there is a piston cylinder arrangement, there is a plunger. If you push the plunger with some force, if you push the plunger with some force, or if you apply a force on some area A, then the pressure will be developed. That is what is the definition of pressure? The normal force per unit area. Whenever the pressure is developed in the viscous liquid, then the pressure will try to make the fluid or the viscous liquid coming out of the holes. The pressure, the developed pressure will make the viscous liquid coming out of the hole. And if you will observe, the flow will be equal or it will be uniform flow from each and every hole. The flow will be uniform. You will observe that it will have uniform flow from each and every hole. It means the flow will be same, the flow velocity will be same, the flow rate will be same from each and every hole. It means the pressure will be equal in each and every direction. The applied pressure will be equal in each and every direction. Hi aspirant, how are you? Kitni rank? 15K. How much is that? 15,000? 52.8 marks. It might be 52.8 marks. There are chances, but the competition is tough. I would say there are chances, but you have to take care of each and every PSUs. You should keep a watch. You might fit in some of the PSUs because most of the students will try to go into the Maharatnas, Navratna, etc. But there are PSUs which higher through gate examination, there might be a chance. 1.5K. There are chances. Definitely there are chances, aspirant. Another statement of Pascal law. Let us talk about Pascal law in another way. The next statement which will give you better understanding about the Pascal law is external static pressure. External static pressure. I told you pressure is an external quantity. External static pressure exerted or developed on a fluid is transmitted uniformly or equally. Whenever we develop the external static pressure in a fluid, then it will be transmitted uniformly throughout the fluid in a horizontal plane. In a horizontal plane, the transmission of pressure will be same. That is another statement of Pascal law. And yes, aspirant, you should give it a try one more time. You should give it a try because you are very close to getting more better rank. So do not leave it in the middle. Better you should try for better rank, better score, better marks, right? The Pascal law, another statement for Pascal law, external static pressure exerted, or you can take an admission in MTech somewhere and then you should give it a try. Or you can take up a job and you should continue your preparation, because now you do not require much time. You do not require the entire year for your preparation. Your preparation is already more than 60%, more than 60-70%. So only 30% of the hard work and dedication is required. Yes. So this will be well understood by the hydraulic press. The application of Pascal law, hydraulic press. Hydraulic press. Have you seen hydraulic press or hydraulic lift or hydraulic jack? These are the instruments which are based on Pascal's law. Now look how it works. The hydraulic press, how it works. If you take a static fluid in a container, if you take static fluid, if you take static fluid in a container and there is a piston here, piston or plunger, we can call it as plunger also, of area A1, and there is a ram. This is the ram of area, let us say A2. A2 is the area of the ram. Now if you exert a force F1 normal to the area A1, if you exert a force F1 normal to the area A1, then that will develop a pressure P1 here. At this point, pressure will be developed P1, which is equal to F1 by A1. Yes or no? There will be a pressure developed. Pressure developed is F1 by A1. Now, according to Pascal law, the same pressure will be transmitted uniformly in the horizontal plane. So we can say pressure here will also be P1. Whatever the pressure developed here, let me call this point to be 2. So it will exert a force F2 on the ram. The pressure will exert a normal force F2. So F2 is equal to P2 into A2. And according to Pascal law, we can say P1 will be equal to P2. Yes or no? That is the Pascal law. According to Pascal law, P1 is equal to P2. So we can say it will not be the force which are equal. It will be the pressure which are equal. So F1 by A1 will be equal to F2 by A2. If you know any of them, we can easily find out F2, that is the ratio of A1 by A2. We can say F2 will be equal to F1 multiplied by A2 by A1. This is how we can find out how much force we will be getting by applying a force F1 on the plunger. So heavy objects can be easily lifted based on the Pascal's law. Look, if we exert a force of 1 Newton, let us say, if you apply a force of 1 Newton on the plunger, if we apply a force of 1 Newton on the plunger, and the plunger area is, let us say, 1 meter square. If the area of the plunger is 1 meter square, if we apply a force of 1 Newton, then the pressure P1 will be equal to 1 Pascal. Yes or no? The pressure P1 will be 1 Pascal. And if the area A2 is 10 times of A1, if the area A2 is 10 times of A1, then the force F2 will be 10 F1, isn't it? So if A2 will be equal to 10 or 100 times of A1, then F2 will be equal to 100 times of F1. Yes or no? That is how by applying 1 Newton of force, we can get 100 Newton of force at the ram, and 100 Newton force can be easily lifted by just applying 1 Newton of force. That is the Pascal's law. I hope this is clear. If anybody is having any doubt, anything to ask, please do let me know. Otherwise, I will make the concept more clear and the concept will be widely used. The third statement will be more widely used. The third statement of Pascal law. Try to understand this one. This is the most important statement. Look, what the Pascal law says, any 2 or more points, if you are having 2 or more points at the same elevation means same height, or in a horizontal plane. Previously also we have mentioned horizontal plane or same height. Horizontal planes means same height, isn't it? Or same elevation. So any 2 points at the same elevation in continuous mass of same static fluid. If the points are lying in the continuous mass of the same static fluid, will always have same pressure. Will always have same pressure. Pressure will be same or pressure will be constant. Or all those points which satisfied these condition. What are the condition? Same elevation, continuous mass of same static fluid, then they will always have the same pressure. So these are the conditions. Condition number 1, same elevation or same height. Condition number 2, continuous mass. It means it must be a single fluid. Continuous mass means single fluid. That is only when it is called as continuous mass. It must be a single fluid. The third condition is static fluid. There should not be any shear stress developed. There should not be any relative motion. There should not be any angular deformation, or there should not be any flow. So they will have the same pressure. If all the above 3 conditions are satisfied, then the pressure will be same. So let us take an example to demonstrate this Pascal's law. If there is a U-shaped tube, if we are having a U-shaped open tube, let us say there is a U-shaped tube and it is having multiple fluid, having the multiple fluids. One fluid is rho 1, another fluid is rho 2, and they are immiscible. Right? Both are open to atmosphere. Both the limbs are open to atmosphere. Here pressure is P atm. Here also pressure is P atm. This is the arrangement, let us say. If I draw a horizontal line, look, if I draw a horizontal line here, now both the fluids are static fluid. If you see, whatever the fluids in the arrangement are static, both the fluids are static fluid, so this condition is always satisfied for all the points. And if we take a horizontal line, and if we take points 1 and 2 on the same horizontal line, then we can say point 1 and point 2 satisfy the condition of same elevation also. Yes or no? They are at the same elevation, same height. Now the third condition is most important. Continuous mass or single fluid. If you join these 2 points, if you join point number 1 and point number 2, if you can join them in the single fluid, if you can join, listen very carefully, if you can join these 2 points in a single fluid, through a single fluid, then it will be called a continuous mass. And if you require more than 2 or more than two fluids, then it will become discontinuous mass. So if you join 1 and 2 from the top, try to understand this. If you join 1 and 2 from the top, we are traveling in rho 1 fluid up to this, then we are traveling in air, and then we are traveling in rho 2 fluid. To join point 1 and 2 from the top, we are traveling in three fluids. Yes or no? We are traveling in three fluids, rho 1, rho 2 and air. But if we join these 2 points from the bottom, are we traveling in multiple fluids? Yes or no? Are we traveling in multiple fluids? If we join point number 1 and point number 2 from the bottom, are we traveling in multiple fluids or a single fluid? Yes, I want your answer for the same. Everyone. Are we traveling in a single fluid or are we traveling in a multiple fluid? Quickly, give me the answer. Give me the answer quickly. Are we traveling in a single or multiple fluids? Waiting for your answer. So from the bottom, point 1 and point 2 are joined by a single fluid only. And that is why we can have the condition number 2 also getting satisfied for point number 1 and 2. And we can comfortably say P1 and P2 will be equal. Isn't it? Pressure at 1 and pressure at 2 will be equal because all the three conditions are getting satisfied. Now, similarly, if I draw a horizontal line like this, horizontal plane, if I take point number 3 here, if I take point number 4 here, if I talk about point number 3 and 4, now I can comfortably say static fluid condition is satisfied. I can comfortably say same elevation condition is satisfied. Now, are the point 3 and 4 joined through a single fluid or multiple fluids? Can we join them through a single fluid or they are joined through the multiple fluid? You have to check from the top. You have to check them from the bottom as well. If you join 3 and 4 from the top, we are traveling in air. Up to this point, air is there and then rho 2 fluid. So we can say there are multiple fluids. There are 2 fluids involved. And if we join 3 and 4 from the bottom, first we are traveling in rho 1 and then we are traveling in rho 2. Again, there are multiple fluids, rho 1 and rho 2 to join them because point number 3 and 4 are not joined by a single fluid at all, neither from top nor from the bottom. So P3 and P4 will not be equal. Pressure at 3 and pressure at 4 will not be equal. Are you getting it? Now, what if the area A1 and A2 are not equal? If A1 is not equal to the area of left leg is not equal to the area of the right leg. If the cross-sectional area A1 is not equal to A2, then will the Pascal law holds true? Or it will not hold true? Will the Pascal law hold true or not? Let me clear you that Pascal's law is nothing to do, has nothing to do with the geometry, area, shape or size. It has nothing to do with the geometry, area, shape or size. It only depends on these properties or these conditions. The Pascal law only depends on the given condition. If the given conditions are satisfied, then the pressure will be equal. If any of the condition is not satisfied, then the pressure will not be equal. And we can have the corollary of Pascal law now. What is corollary? Or the results of Pascal law, we can have the corollary. What is the meaning of corollary? There are 4 conditions. We can say there are 4 conditions. There are 4 conditions. Same elevation, continuous mass, static fluid and same pressure. If any of these 4, if any 3 conditions are satisfied, then the 4th one will also be true. Pascal law corollary says if any 3 conditions satisfies, then fourth condition will also be true. If any three conditions get satisfied, then the fourth condition will also be true. What are the conditions? One is same elevation, same height. The second condition is single fluid or continuous mass. The third condition is static fluid. And the fourth condition is equal pressure, same pressure. Out of these four conditions, if any three conditions are satisfied, then the fourth condition will also be correct. Let us take an example. There are open tubes there is a container. Let us say there is a container and which is having multiple tubes, open tubes. All the tubes are open with open tubes. And we start pouring some liquid. If we pour some liquid or water in any one, if we start pouring water in the container through one of the tube, then what will happen? The water will first fill the container or the tank. Water will first fill the container, and then if we will continue pouring the water, then it will start rising in the tubes. The water will start rising in the tubes which are having different shapes, sizes, dimensions, area, etc. Water will start rising in the tubes. And if we stop pouring the water, now if we stop pouring the water, then what will happen? Try to understand. Then if we talk about these points, this is, let us say, point number A, the free surface. This is the free surface, point number B. This is the free surface of the third tube, point number C. This is the free surface of fourth tube, point number D, and this is point number E. All right. Now, can we say the water is static in the container and the tubes? Now we have stopped pouring the water. Now it is a static fluid. It is not moving. It is having no flow, no deformation. Water is static in the container. So this condition is always satisfied. Now because all the tubes are open to atmosphere, so can we have the atmospheric pressure everywhere at the top? The atmospheric pressure. The pressure is P atm. The pressure is P atm everywhere. So fourth condition will also be getting satisfied for point A, B and C. PA will be equal to, we can say, as PA is equal to PB is equal to PC is equal to PD is equal to PE is equal to constant. That is P atm, yes or no? Because all the tubes are open to the atmosphere. Pressure will be same. And it is a single fluid. If you join A and B, then we can travel only in water to join A and B. To join B and C, we can only travel in the water. To join C and D, we can only travel in the water. To join D and E, we can only travel in the water. So it is a single fluid or continuous mass. Yes or no? So second, third and fourth conditions are getting satisfied. So implies point A, B, C, D and E will lie in same horizontal plane. Yes or no? If you join point A, B, C, D, E, it will be the same horizontal line. They will lie in the same horizontal line. That is according to Pascal's law. According to Pascal's law, they will lie in the same horizontal plane. Right? If we take point P here at the bottom, if we take point P at the bottom of tank, bottom of the tube, if we take point P at the bottom of the tube 1, point Q at the bottom of tube 2, point C, QR, point R at the bottom of tube 3rd, S at the bottom of the tank, bottom of the tube 4th, and T. If we talk about PQRST, these are the points. If we talk about PQRST, now PQRST are lying in the same horizontal plane. Yes or no? PQRST are lying in the same horizontal plane. So they are lying in the same height. PQRST are part of the static fluid. The fluid is static. The water is static in the container, in the arrangement. PQRST are joined by the same fluid. If you join P and Q, we can only travel in water. Q and R, R and S, we can travel only in water. So these are the three conditions getting satisfied. These are the three conditions getting satisfied. Then according to Pascal law, the fourth condition will also be true. What is that? So also we can say PQ will be equal to, PP, pressure at P, will be equal to pressure at Q, will be equal to pressure at R, will be equal to pressure at S, will be equal to pressure at T, will be constant, will be same. Pressure at P, Q, R, S, T will be same irrespective of size of the tube, shape of the tube, and area of the tube. I told you Pascal law has nothing to do with the shape, size, area, etc. The pressure at P will be same as pressure at Q, will be same as pressure at R, will be same as pressure at S, will be same as pressure at T. Is this all clear to everyone? Yes, anybody is having anything to ask, do let me know. If anybody is having anything to ask, please do let me know. Can we proceed further? Yes. Is this all clear? Now there is a question waiting for you. Try to solve this question. A hydraulic press which is based on Pascal's law. A hydraulic press has a ram of 15 centimeter diameter. Diameter is given. It means D2 is given. And plunger of 1.5 centimeter diameter. D1 is given as 1.5 centimeter. Now it is to require to lift a mass of 1000 kg. So this is F2, that is M2 into G. F2 is M2 into G. M2 is, this is mass is 1000 kg. The force required on the plunger F1 will be how much? So according to Pascal law, we can say P1 is equal to P2. That implies F1 by A1 is equal to F2 by A2. The question is to find out F1. So we can say F1 is equal to F2 into A1, that is pi by 4 D1 square upon A2 pi by 4 D2 square. Pi by 4 getting cancelled out. So F2 is equal to 1000 into 10 M2 into G into D1 1.5 upon D2 15 centimeter square. So what is that? That will be 1000 into 10 upon 10 into 10. Yes or no? 10 getting cancelled out. This 100 Newton will be the value of F1. 100 Newton should be the value of F1. This is how the questions can be framed. I hope this is clear. I hope this is clear to everyone. So do not forget, there is an important information, guys, before we proceed further. If anybody is having anything to ask, please do let me know. And do not forget to like and share this session so that it reaches to all the students who are sincerely preparing for GATE 2025. And to make your preparation simple and result oriented, there will be an important workshop which is going to be conducted tomorrow at 7:30 p.m. That is completely free workshop and taken by Rakesh sir, He is MTech from IIT Bangalore and he has got All India rank 9, having more than 12 years of experience, and the workshop is all about getting a good score in GATE 2025. How to prepare, what are the things you need to take care. It will be very helpful before starting your preparation so that you get better rank, better scores with the minimum efforts. So do not forget to be part of this workshop. The link is already there in the description box. The link is already there in the description box. All right. And one more information, on 14th of April, we will be having the scholarship test, national level scholarship test for GATE exam, where the syllabus will be mathematics and aptitude, and based on your performance in the scholarship test, you can get our course at a very discounted price. You can get up to 90% of a scholarship, and let me tell you, if you are sincere in your preparation, you should join a institute. Yes, because with the right guidance only you can get a better score, you can get a better rank in your examination. You can have the systematic preparation approach when you will be having the guidance throughout your preparation journey. So it is always preferred to join a course, and you can get our course at a very cheap price. Again, the link to register yourself is already there in the description box. Let us come back to the point. Now I will talk about a couple of more terms regarding the pressure. One is called as atmospheric pressure. Atmospheric pressure, PATM. What is atmospheric pressure? Pressure which is exerted or which is developed by the environmental mass or atmosphere. The pressure which is exerted by the atmosphere is known as atmospheric pressure. For an example, Earth is having an atmosphere, and the pressure which is exerted on the Earth's surface by the atmosphere above it, above any point, will be the atmospheric pressure. So it is different at poles, it will be different at equator, because the Earth is not round. So that is why the atmospheric pressure will be different at a different location. So we can say it is nothing but the weight of air. Mathematically, it is the weight of air above a particular location per unit surface area. Weight of air above a location per unit surface area, and that is the reason it varies with the location. It varies with the location. It varies with the weather condition also. So atmospheric pressure is always a local quantity. It is always a local or variable quantity. Local or variable quantity, isn't it? If I ask you what is the standard atmospheric pressure, whenever the atmospheric pressure is not given, if we want to have the standard atmospheric pressure, then that is 1 atm or 1.013 bar, or we can say 101.3 kilopascal, or we can say 1.013 into 10 to the power 5 Pascal. 1.013 into 10 to the power 5 Pascal, or we can say it is 760 millimeter of mercury column. That is the standard atmospheric pressure, but we are not interested in the standard atmospheric pressure. We always are interested in the local atmospheric pressure or the variable atmospheric pressure, which changes with the location and with the weather condition, and that is measured by an instrument called as barometer. The instrument is called as barometer, which measures the local atmospheric pressure. The instrument is called as barometer, and the local atmospheric pressure is also called as barometric pressure. We can also call it as barometric pressure. Local atmospheric pressure is also known as barometric pressure. How it changes with location and weather condition? With height, if you see, with height, local atmospheric pressure decreases. With height, the local atmospheric pressure decreases. Atmospheric pressure decreases with height. At the ground, the atmospheric pressure is high. At the higher elevation, the atmospheric pressure becomes lesser, because it is the weight of air above a location. The weight of air will be this, but here the weight of air will be this. So this will decide the atmospheric pressure. And with weather condition also, if the sky is clear, this will be the atmospheric pressure. So if the sky is clear, then it will have high atmospheric pressure. Clear sky, atmospheric pressure is high. And cloudy weather, atmospheric pressure is low. When cloudy weather, it becomes low atmospheric pressure. And this barometer is the instrument which can be used to have the weather forecasting. So this is about the local atmospheric pressure. This is about the atmospheric pressure. Now there are two more terms, absolute pressure and gauge pressure. Absolute pressure and gauge pressure, how they are defined? This is, let us say, absolute vacuum or absolute zero. Absolute vacuum or absolute zero. If the pressure is measured from the absolute zero as the reference, then we get the absolute pressure. This is the absolute pressure at any point. This is the point we are talking about. This is the point which is having the pressure PA. If the pressure is measured having the absolute zero as the reference, absolute zero, 0 Pascal as the reference, then it is the absolute pressure. If this is the local atmospheric pressure. If the pressure at the same point is measured with respect to the local atmospheric pressure, then it is called as gauge pressure, PG. Then it is called as gauge pressure. So we can say from the given figure, we can say absolute pressure at any point is the sum of atmospheric pressure plus gauge pressure, isn't it? Absolute pressure at a point, or we can say gauge pressure at a point is equal to absolute pressure minus atmospheric pressure, local. This is how we can find out the gauge pressure. For an example, if PATM is equal to 1.2 bar, let us say, or 1 bar. If the atmospheric pressure is 1 bar. For an example, if the atmospheric pressure is given as 1 bar, that is the local. At a particular location, the atmospheric pressure is 1 bar. And PA absolute is equal to 1.2 bar. PA absolute is 1.2 bar. Then what will be the gauge pressure? What will be the gauge pressure? If the absolute pressure is 1.2 bar, then what will be the gauge pressure? The gauge pressure can be calculated by absolute pressure minus atmospheric pressure in the same unit. Absolute pressure minus atmospheric pressure to be in the same unit. Both are in bar. So 1.2 minus 1, that is 0.2 bar. Yes or no? That is positive. But if the gauge pressure, at a point B is minus 0.2 bar, there is a difference between positive 0.2 bar and negative 0.2 bar, then what will be the absolute pressure at B? What will be the absolute pressure at B? It is PATM plus PG. PG can be positive, it can be negative. So the gauge pressure must be used with sign and the atmospheric pressure must be used as local one, and we will get the absolute pressure in the same unit as that of atmospheric pressure and gauge pressure. If the gauge pressure is minus 0.2 bar, then the absolute pressure will be 1 plus minus 0.2, that is 0.8 bar. Yes or no? So 0.8 bar will be the absolute pressure at point B. The point B will be somewhere here. Point B will be lying below the atmospheric pressure line, or point B is having the pressure, absolute pressure which is less than atmospheric pressure. That is called as vacuum pressure. Negative gauge pressure is known as vacuum pressure. So this is how we can have an understanding about the absolute pressure, gauge pressure, and so we can say negative gauge pressure is also known as vacuum pressure. Why it is called as vacuum pressure? Because the pressure is less than atmospheric pressure. That is why it is called as vacuum pressure, negative gauge pressure. So PB can also be called as 0.2 bar vacuum. We can call PB, pressure at B, to be 0.2 bar vacuum. It means it is having minus 0.2 bar gauge pressure. Now there is a question on the screen. Let us solve this question. The standard atmospheric pressure is 101.32 kilopascal. The standard atmospheric pressure. The local atmospheric pressure is 91.52. I told you we are not interested in the standard atmospheric pressure. We are always interested in the local atmospheric pressure which the barometer reads. If a pressure at a flow path is recorded as 20.48 kilopascal gauge, then it is equivalent to absolute pressure will be equal to atmospheric pressure, that is the local one, plus the gauge pressure. Yes or no? Gauge pressure is positive, you should be put it with the sign. If it is negative, put the value of gauge pressure with the negative sign. So absolute pressure is, it will be 91.52 plus 22.48 kilopascal will be the absolute pressure. You should not use this 101.32. You should not use this 101.32. So how much is that? 0, 549, again 0, 1, 2, 1, 3, 4, 104 kilopascal. 114 absolute. P absolute will be equal to 114 kilopascal. Yes, that is all about the Pascal law. If anybody is having anything to ask, any doubt, if you want me to repeat any of the concept, please do let me know. You can see our performance or Byjus exam prep students performance in the GATE 2024. So two things are very much required for clearing the GATE or any other competitive examination. One is your hard work and the second one is the right guidance. So if you are having the right guidance and if you are ready to do the hard work, then nobody can stop you from getting the success. And for the right guidance, you can join our vision courses for 2025 or for 2026, where we cover the entire syllabus in detail, along with the study material to be provided, quizzes to be given, mock test access will also be there, and recording class will also be provided to you in case you miss any of the classes. So the entire package will be provided to you if you become part of our paid course. And to know more about the paid course or to know more about your career, you can always connect with our counselor through this given number, or you can just fill the counseling form which is there in the description box to have one-to-one discussion regarding your career, regarding our courses, regarding anything related to your preparation. We will be more than happy to assist you in every possible way. All right. So this is your assignment question. This is assignment number 1. Try to solve this question. Very simple question based on hydraulic device, hydraulic press. Bring me the answer in tomorrow's class. One more homework I am giving you. Try to solve these questions and share your answer through the comment section. This is MSQ. All right. So these are the questions. You can take the screenshot if you like for these two questions. And tomorrow I will be talking about the hydrostatic law. after the Pascal law, it is important for you to understand the hydrostatic law, right? This was question number 1. And not only this foundation course, you must be knowing, if you do not know, we are running another course, that is Ground Zero series, on our Byjus exam prep app for all the branches. Forget 2025 aspirants. In Ground Zero series also, we give you the practice, we discuss the numericals, we discuss the concept from the ground zero, from the basics, and we make you to understand the advanced concepts as well gradually. So what you need to do is, you just download our Byjus exam prep app through the Google Play Store, or there is a bit.ly link in the description box. You can click on that link to download our Byjus exam prep app. So once you download the app, you will be getting the access to all our free sessions, all our quizzes. You can practice some numericals through the quizzes also, which are available there, right? So that is all from my side. Again, I am sharing my contact details. I am sharing my link to join me on the Telegram, Mechanical by Chandrasekhar, or you can scan the QR code. This is all from my side for the day. Tomorrow we will be meeting again. We are going to meet again tomorrow at 6 p.m. and we will discuss the technicalities of hydrostatic law. All right. So do not forget to join me on the same platform tomorrow at 5 p.m. So that is all from my side, guys. Thank you very much for joining in. Take care, stay safe, stay motivated, and see you in the next session, and solve these questions and come little prepared so that you can involve yourself more and more to understand the concept. All right. Thank you very much, guys. Once again, see you tomorrow. Jai Hind.